Now, in this lecture, we find out the ratio between two radii. In the drawing, we have a big circle. Inside this big circle, we have two small circles. The radius of this circle is B, the radius of this circle is A, and also triangle, the right triangle ABC is partially located in the biggest circle. Angle ABC equals to 90 degrees, side AB equals to 5 units in its length, side BC equals to 12 units in its length, and we also know that AN equals to NC. Our mission is to find out the ratio between the two radii, that is to say the ratio of B over A. Okay. So first of all, we implement the Pythagoras theorem on the right triangle ABC. So, according to the Pythagoras theorem, on the right triangle ABC, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AC square equals to AB square plus BC square. Repeat again. According to the Pythagoras theorem, the right triangle ABC, AC square equals to AB square plus BC square. So AC square equals to AB square. AB is 5, therefore AB square is 5 squared, that is 25, plus BC square. BC is 12, therefore BC square is 12 squared, that is 144. So AC square equals to 25 plus 144 is 169. We take out of this equation and we get that AC equals to the square root of 169, it is 13. So here, the hypotenuse AC of the right triangle ABC is equals to 13 units in its length. And we know that at point N, the hypotenuse AC is bisected into two halves. The first half is AN and the second half is NC. So I can write down that AC over 2 is equal to 13 over 2 is equals to the first half, that is AN, and it is also equals to the second half, that is NC. We found out that 13 over 2 equals to AN equals to NC, that is to say AN equals to NC equals to 13 over 2. So you can write here that NC equals to 13 over 2 units in its length. In the next step, I present to you a new rule and implement the new rule in our drawing. This is rule number 8. According to rule number 8, the radius of a circle that is bisected that is blocked by a right triangle, radius R equals to A plus B minus C over 2. So we have here the right triangle ABC. The right triangle ABC blocks this circle. And we also know, so the radius of this circle is R. the length of side AB of triangle, the right triangle ABC is A, side BC equals to B units in strength, the hypotenuse AC equals to C units in strength. Actually, the meaning of rule number 8 is that we can know the value of the radius of a circle that is blocked by a right triangle only by knowing the length size of the right triangle, or the side length of the right triangle. That is to say, the radius will be equal to A plus B minus C over 2. Okay, so we can implement rule number 8 in our drawing. Here we have, this is the right triangle ABC. The right triangle ABC blocks the circle. So the radius A of this right triangle, according to rule number 8, will be equal to AB plus BC minus AC over 2. So the radius A equals to AB, that is 5, plus BC, that is 12, minus AC, that is 13 over 2. So I'll write it down. The radius A of this circle, according to rule number 8, the radius A will be equal to AB, that is 5, plus BC, that is 12, minus the length of the hypotenuse AC, that is 13, over 2. So this equation is the implementation of rule number 8 in our drawing. 5 plus 8 is 17, 17 minus 13 is 4, and 4 over 2 is 2. So in conclusion, we found out that the radius A of the small circle equals to 2 units in its length. Here, A equals to 2 units in its length. AB is tangent to the circle at this point. We define the point of tendency as T. We define the center of this small circle as P. We join points P and T together by a straight line. Point P is the center of the circle. Point T is the point on the circle itself. This is exactly the definition of a radius. So PT is the radius of this circle that is equal to A, that is equal to 2. The radius PT is drawn to point T, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius TP. If AB is perpendicular to TP, this is according to rule number 1, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, we define the point of tendency of tangent BC with this circle as N. We join points P and then together by straight line. Pn is the radius of this circle that is equal to 2. The radius Pn is drawn to point N, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius NP. If BC is perpendicular to NP, it means that this angle equals to 90 degrees, and this angle is also equal to 90 degrees according to rule number 1. So in quadrilateral TPBN, we have 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the fourth angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. So inside quadrilateral TPBN, we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we will relate to quadrilateral TPBN. It's a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, TP equals to BN, but TP is 2, therefore BN must be also equal to 2. Likewise, side PN of triangle of rectangle TPBN must be equal to the opposite side TB, but PN equals to 2, therefore TB must be also equal to 2. So actually we found out that quadrilateral TPBN is not a rectangle but a square. Why? Because all of its sides are equal to each other. It is given us in the question that BA equals to 5 units. So AB minus TB, again AB minus TB equals to 80. AB is 5, TB is 2, 5 minus 2 is 3, so 80 equals to 3. Okay. We have the common external point, point A. From the common external point A, we have two tangents to this circle, tangent AT and tangent AM. And according to rule number 2, it states that the lengths of two tangents from common external point to a circle are equal. We get that AT equals to AM, but AT is 3, therefore AM must be also equal to 3. We have already found out that AN equals to 13 over 2. It is one half of AC that equals to 13 units is length. It is one half of the hypotenuse AC that is equal to 13, therefore AN is 13 over 2. So AN minus AM equals to MN. Write it down. AN minus AM. AN minus AM equals to MN. AN is 13 over 2, AM is 3, and is equal to MN. Here we'll multiply 3 by 2 and then we divide it by 4. No, we'll multiply 3 by 2 and then we divide it by 2 in order to account factor of 13 over 2, and we get that 13 over 2 minus 3 times 2 is 6, so it is 13 over 6 over 2. 13 over 6 is 7, so in total this expression equals to 7 over 2. So in conclusion, we found out that Mn equals to 7 over 2. Mn equals to 7 over 2. You can write here that Mn, this line segment Mn equals to 7 over 2 units in its length. In the next step, we'll define the center of this circle as Q. We'll define the center of the biggest circle as O. And the next step will present to you a new rule, and we will implement the new rule number 7 in our drawing. According to rule number 7, if a line segment that is drawn from the center of a circle bisects the chord, then the line segment is also perpendicular to the chord. The center of this circle is here at point O. From the center of this circle, that is to say from point O, we draw line segment OM that bisects chord AB. That is to say AM equals to MB. And whenever you have from the center of the circle a line segment that bisects the chord, then it will not only bisect the chord, but it will be also perpendicular to the chord. So line segment OM will be perpendicular to chord AB. That is to say this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 7. So whenever you have from the center of the circle a line segment that bisects the chord, it will be also perpendicular to the chord. Here, because of the fact that OM bisects chord AB, that is to say AM equals to MB, Therefore, OM will be also perpendicular to AB. That is to say, this angle will be equal to 90 degrees, and this angle will be equal to 90 degrees according to this rule number 7. So we can actually implement rule number 7 in our drawing. We join points O and N together by straight line. ON is a line segment that is drawn from point O, that is the center of the biggest circle. Line segment ON bisect chord AC. Why? Because AN equals to NC according to what is given as the question. And because of the fact that line segment ON that is drawn from the center of the circle, that is to say from point O, bisect chord AC, it will not only bisect the chord AC, but it will also be perpendicular to chord AC. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees, according to rule number 7. So we can write down that ON is perpendicular to AC. Okay? ON, line segment ON is perpendicular to AC. Point Q is the center of this circle. Point N is the point of the circle itself. Therefore, Qn is the radius of this circle that is equal to b units in length. The radius Qn is drawn to point N, that is the point of tendency AC with this circle, and whenever a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NQ. If AC is perpendicular to NQ, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. So we can write down that Qn is also perpendicular to AC. Qn is perpendicular to AC. And from those two equations, ON is perpendicular to AC and Qn is also perpendicular to tangent AC, we will derive that point O lies on the radius Qn. Okay. This is point O, that is the radius of the bigger circle, lies on the radius Qn. Point O must lie on the radius Qn, otherwise either ON will not be perpendicular to AC, or Qn will not be perpendicular to AC. In order that both ON and also Qn will be perpendicular to AC, point O must be located on the radius Qn. Or in other words, QON is one straight line. QON is one straight line. QON, line segment QON is one straight line. at this point, this circle touches the biggest circle. We define the point of tendency of the touching point between the two circles as U, and then we go tangent VW. Tangent VW is tangent to both circles at point U. Again, tangent VW is tangent to both circles at point U. So point Q is the center of this circle. Point U is a point on the circle itself. Therefore, QU is the radius of this circle. The radius QU is drawn to point U, that is the point of tendency of tangent VW with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius UQ. If VW is perpendicular to UQ, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. So I can write down that QU is perpendicular to VW. QU is perpendicular to tangent VW. Okay, again, the radius QU is perpendicular to tangent VW. Likewise, point U is the center of the biggest circle. Point U is the point of the biggest circle itself. This is exactly the definition of a radius. So OU is the radius of the biggest circle that we define as X. The radius OU is drawn to point U, that is the point of tendency of tangent VW with the biggest circle. Whenever we have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius OU. That is to say, this angle will be equal to 90 degrees and this angle equals to 90 degrees according to rule number 1. So I can write down also that OU is also perpendicular to VW. OU is also perpendicular to tangent VW. And from those two equations, QU perpendicular to tangent VW and OU is also perpendicular to tangent VW, we will derive that OU is one straight line. Repeat again, this line segment OQU is one straight line. So from one side, OQU is one straight line, but for the other side, we have already found out that QON is also one straight line. And from those two statements, we derive that in total, NQU is one straight line. NQU is one straight line. And QU is a straight line. And if NQU is a straight line, it means that NQ is if NQU is a straight line, it means that NU is also a straight line. But NU, the straight line NU touches the circle at point U and N. That is to say, NU is a chord that passes for point Q, that is the center of this circle, and any chord that passes for the center of the circle must be the diameter of the circle. Therefore, NU is the diameter of this circle. So I can write down that chord NU is the diameter of the circle. NU is the diameter of the circle. And we also know that the diameter of any circle is twice as long as the radius, and the radius of this circle is b, therefore the diameter in u must be equal to 2b. Diameter in u must be equal to 2b. Okay. And u equals to 2b. The next step, we join points O and P together by a straight line. Point O is the center of the bigger circle, point P is the center of the smaller circle. The bigger circle and the smaller circle have an internal notch between them. At this point we define the touching point as S. That is to say, the bigger circle and the smaller circle touch each other internally at point S. Okay, and we have here hole number 9. According to hole number 9, if two circles touch each other internally, then the straight line that connects their centers together passes through their touching points. The center of the biggest circle is at point O, the center of the small circle is at point M. The straight line that connects their centers together is the straight line OM, and according to this rule number 9, the straight line OM must pass through point P, that is their touching point. Or OMP is one straight line. Again, OMP is one straight line. Okay, OMP is one straight line. We can implement rule number 9 in our drawing. Why? Because in our drawing, the smallest circle and the biggest circle touch each other at this point S. That is to say, they have an internal notch between them at point S. So the straight line OP that connects their centers together must pass through point S. Or OPS is one straight line. And I know that OPS, line segment OPS is one straight line. And therefore, we get that OS minus SP equals to PO. Again, PO minus SP equals to, again, SO. This line segment is SO minus SP equals to PO. SO minus SP equals to PO. So I write it down, SO minus SP equals to PO. What is the definition of line segment SO? This line segment SO. Line segment SO starts, or OS starts from point O, that is the center of the biggest circle, and ends at point S, that is a point on the biggest circle itself. This is exactly the definition of a radius. Therefore, OS is the radius of the biggest circle, that is equal to X according to our definition. So we substitute SO by X minus SP. We already found out that SP is the radius of this circle that is equal to 2 units. We substitute SP by 2. So in total we found out that PO equals to X minus 2. I'll write it down again. That PO equals to X minus 2. This line segment PO equals to X minus 2 units in its length. In the next step, we will extend perpendicular ON by a straight line. Define this point as T. ON is perpendicular, it is absolutely a straight line. When we extended the straight line ON by a straight line, the result is OT. When we extend the straight line by a straight line, the result must be a straight line. So OT is a straight line. If we focus on this side of the straight line, OT is point N. Here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at this side of 48.10? We have this angle that is equal to 90 degrees plus the missing angle. In total, they must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees. AC is tangent to the small circle at point M. Point M is the point of tendency. We join points P and M together by a straight line. Point P is the center of the small circle, this small circle. Point M is the point of the circle itself. Therefore, PM is the radius of the circle. Is equal to A and A equals to 2. The radius PM is drawn to point M, that is the point of tendency of tangent AC with this small circle. And whenever you have a radius that is drawn to the point of tendency, that is to say to point M, that is the point of tendency, then tangent AC will be perpendicular to the radius MP. If AC is perpendicular to MP, it means that this angle equals to 90 degrees, and this angle equals to 90 degrees according to rule number 1. The next step we will do a construction. We will draw perpendicular on the radius PM at point P. Again, we will draw perpendicular on the radius PM at point P. So actually, this angle equals to 90 degrees according to our construction. So in quadrilateral PM and T, we have 1, 2, 3 right angles. Therefore, the fourth angle must be equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to quadrilateral PM and T that has 4 right angles as a rectangle. We know that the opposite sides of a rectangle are equal to each other. That is to say PM equals to TN, but PM is 2, therefore Tn or Nt must be also equal to 2. We define the length of line segment NO as H. The opposite sides of rectangle MN equals to each other. That is to say PT equals to MN, but MN is 7 over 2, therefore PT must be also equal to 7 over 2. In the next step, we will implement the Pythagoras theorem on the right green triangle POPT. This big this right green triangle OPT. What is the length of PT? What is the length of TO? TO equals to 2 plus H. TO equals to Tn plus NO. Tn is 2 and NO is H, so in total TO equals to 2 plus H. We have already found out that PT equals to 7 over 2, and we have already found out that PO equals to x minus 2. PO equals to x minus 2. PO equals to x minus 2. The hypotenuse PO equals to x minus 2. So actually, this is the right triangle OPT that they copied from the original drawing. The hypotenuse PO is x over 2. Here, PT equals to 7 over 2, and OD equals to 2 plus h. So according to the Pythagoras theorem, PO squared equals to PT squared plus TO squared. PO is x over 2, therefore PO squared is x minus 2 squared is equal to PT squared. PT is 7 over 2, therefore PT squared is 7 over 2 squared, that is 49 over 4. Plus TO squared. TO is 2 plus h, therefore TO squared is 2 plus h squared. We'll open the brackets on both sides of this equation and we get that x minus 2 squared equals to x squared plus 4 minus 4x. That equals to 49 over 4 plus 2 plus h squared equals to 2 squared, that is 4 plus h squared plus 4h. In the next step, we will join point C and O together by straight line. Point O is the center of the biggest circle. Point C is the point of the biggest circle itself. Therefore, OC is the radius of the biggest circle, that is equal to x. PO equals to ON equals to h, and NC equals to 13 over 2. So I copy the right triangle PONC in a new page and we implement the Pythagoras theorem on this right triangle ONC. So this is the right triangle ONC, the covered from the original drawing. Therefore, this OC equals to x, ON equals to h, and NC equals to 13 over 2 according to the Pythagoras theorem in the right triangle ONC. OC squared equals to ON squared plus NC squared. OC is x, therefore OC squared is x squared, that equals to ON squared. ON is 8, therefore ON squared is 8 squared plus NC squared. NC is 13 over 2, therefore NC squared is 13 over 2 squared, that is 169 over 4. So in conclusion, we found out that x squared equals to 8 squared plus 169 over 4. So actually, now we can substitute x squared here in this equation by x squared plus 169 over 4. We'll do it now and we'll get that x squared is 169 over 4 plus h squared plus 4 minus x squared plus 4 minus 4x and it equals to 49 over 4 plus 4 plus h squared plus 4h. So this is the equation that we got after we substitute x squared by 169 over 4 plus h squared. So here we have h squared on both sides of the equation, so h squared will get cancelled. And we have 4 on both sides of the equation, so 4 also will get cancelled. And we have to leave with 169 over 4 minus 4x. That is equal to 49 over 4 plus 4h. Here we subtract 49 over 4 from this equation, and you get that 169 minus 49 over 4 minus 4x equals to 4h. Here we get 4x from this equation, and finally we get that 169 minus 49 is 120, so in total this expression equals to 120 over 4 is equal to 4x plus 4h. Here we take 4 as the current factor for those two expressions, so inside the brackets we left with only x plus h, and 120 over 4 is 30. So in total we found out that 30 equals to 4 times x plus h. We divide this equation by 2, and we get that 15 equals to 2 times x plus h. It again, 15 equals to 2 times x plus h. Here we divide this equation by 2, and finally we get that x plus h equals to 15 over 2. X plus h equals to 15 over 2. What is the value of line segment UN? From the drawings it is very easy to see that UN equals to UO plus ON. UO plus ON. That is to say it is equals to UN equals to UO, that is x, the radius of the biggest circle, plus ON, that is h. So in total UN equals to x plus h. UN equals to x plus h. You can write down that UN equals to x plus h on one side, but from the other side we already found out that UN is the diameter of this circle, that is equals to 2b. I'll repeat again. We already found out that UN equals to 2b, here UN or U and U is the same. UN equals to 2b. This is the diameter of this circle. So you can write there that UN is also equals to 2b. And from those two equations, UN equals to x plus h and UN equals to 2b, we derive that x plus h equals to 2b. Okay. x plus h equals to 2b. But we already found out that x plus h, it is also equals to 15 over 2. So we can write here that x plus h equals to 15 over 2. And for this equation, 15 over 2 equals to x plus h equals to 2b. We derive that 15 over 2 equals to 2b. Here we divide this equation by 2. And we get that b equals to 15 over 2 over 2 is 15 over 4. Finally, we found out that the radius of this circle b equals to 15 over 4. And we already found out that the radius of this circle a is equals to 2. So the ratio b over a is equals to b, that is 15 over 4 over 8, that is 2. 15 over 4 over 2 is 15 over 8. Terms of numbers is equals to 1.875. In conclusion, we found out that b over a equals to either 15 over 8 or to 1.875. And that is the answer to our question. In the next step, I'll summarize the lecture. In this lecture, I found out the ratio between the two at the eye, the radius of this circle and the radius of this circle. That is to say, the ratio of b, that is the radius of this circle, over a, that is the radius of this circle. It is given us in the question that we have this big circle, inside this big circle we have the two smaller circles. Again, the radius of this circle is b, the radius of this circle is a. In addition, we have triangle ABC that is partially located inside the biggest circle. The length of side AB is of triangle, the right triangle ABC is 5 units. Side BC equals to 12 units in length. And we also know that AN equals to NC. Again, our mission is to find out the ratio of B over A. So first of all, we implemented the Pythagoras theorem on the right triangle ABC. This right triangle ABC. According to the Pythagoras theorem, AC squared equals to AB squared plus BC squared. And again, in the right triangle ABC, according to the Pythagoras theorem, by PT is the version for Pythagoras theorem, AC squared equals to AB squared plus BC squared. So AC squared equals to AB squared. AB is 5, therefore AB squared is 5 squared, that is 25, plus BC squared. BC is 12, therefore BC squared is 12 squared, that is 144. So in total, AC squared equals to 25 plus 144, that is 169. AC squared equals to 169. We took out of this equation. And found out that the square root of 169 is 13. So AC, the hypotenuse of the right triangle ABC, AC is equal to 13 units in its length. Because of the fact that AN equals to NC, it means that at point N, the hypotenuse AC is bisected into two halves. The first half is AN and the second half is NC. That is to say, AC over 2, that is 13 over 2, equals to the first half of the hypotenuse, that is AN, and it is also equals to the second half of the hypotenuse, that is NC. So from this equation, we derive that AN equals to NC, it equals to 13 over 2. This line segment NC equal to 13 over 2. It is half of the hypotenuse AC. Then I presented to you rule number 2 and you implemented rule number 2, rule number 8 and you implemented rule number 8 in our drawing. According to rule number 8, the radius of a circle that is bisected, that is blocked by a right angle, the radius R equals to A plus B minus C over 2. We have the right angle ABC, angle ABC equals to 90 degrees, the length of side AB is A units, side BC equals to B units in length, and the length of the hypotenuse AC is units. The right angle ABC blocks this circle and the radius of this circle R. The meaning of rule number 8 is that we can find out the radius of this circle that is blocked by the right angle ABC only by knowing the side lengths of the right triangle ABC that blocks the circle. That is to say, the radius will be equal to A plus B minus C over 2. Again, the radius of this circle that is blocked by the right triangle ABC equals to A plus B minus C over 2. We can implement number 7 in our drawing. Why? Because in our drawing we have the right triangle ABC that blocks this circle, and the radius of this circle is A. According to rule number 8, the radius of this circle A will be equal to AB plus BC minus AC over 2. Again, the radius A equals to AB plus BC minus AC over 2. Okay. AB is 5, BC is 12, and AC is 13. So in total, A will be equal to 5 plus 12 minus 13 over 2. Repeat again. According to rule number 8, the radius A will be equal to 5 plus 12 minus 13 over 2. 5 plus 12 is 17, and 17 minus 13 is 4, and 4 over 2 is 2. So we found out that the radius A of the small circle equals to 2 units in its length. A equals to 2. Then we define the point of tendency of tangent AB with this circle as T. We define the center of this circle as P. We join points T and P together by a set line. Point P is the center of the circle, point T is the point of the circle itself, therefore PT is the radius of the circle, is equal to A, and A equals to 2. So PT equals to 2. The radius PT is drawn to point T, that is the point of tendency of tangent AB with this circle, and whenever we have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius TP. If AB is perpendicular to TP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. This is according to rule number 1. Then we define the point of tendency of tangent BC with this circle as N. We join points P and N together by a set line. Pn is the radius of this circle that is equal to 2. The radius Pn is drawn to point N. That is the point of tendency of tangent BC with this circle. And whenever we have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius NP. If BC is perpendicular to NP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. So inside the quadrilateral PTBN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, plus the missing angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle must be equal to 90 degrees. So inside quadrilateral PTBN, we have 4 right angles. Any quadrilateral that has 4 right angles must be this rectangle if not a square. So we relate to quadrilateral PTBN as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle PTBN, Pn equals to Tb, but Pn equals to 2, therefore Tb must be also equal to 2. Likewise, Pt must be equal to Bn, but PT equals to 2, therefore BN must be also equal to 2. So TB equals to 2. AB equals to 5, according to what is given as the question. So AB minus TB is 80 again. AB minus TB equals to 80. AB is 5, TB is 2, therefore 5 minus 2 is 3, so 80 is 3. Then we have the common external point A. From the common external point A, we have two tangents to the circle. Tangent AT and tangent AM, and according to rule number 2, they are equal to each other. That is to say, AT equals to AM, but AT is 3, therefore AM must be also equal to 3. AN equals to 13 over 2. AM equals to 3. So AN minus AM equals to MN. Again, AN minus AM equals to MN. Again, AN minus AM equals to MN. AM is 13 over 2, AM is 3. So equals to MN. We multiplied 3 by 2 and then we divided by 2 in order to have a common factor with 13 over 2. So 13 over 2 minus 3 times 3 is 6, 3 times 2 is 6. So in the numerator we have 13 minus 6, this is 7 over 2. So in conclusion, found out that Mn equals to 7 over 2 units in its length. This line segment Mn equals to 7 over 2. Then I presented to you rule number 7 and we implemented rule number 7 in our drawing. According to rule number 7, if a line segment that is drawn from the center of a circle bisects the chord, then the line segment is also perpendicular to the chord. Here we have this circle. The center of the circle is 0.0. From the center of the circle, that is to say from point O, we draw perpendicular on chord AB. Or from the center of the circle, that is to say we draw line segment OM that bisects chord AB. That is to say AM equals to MB. So whenever a chord from the center of a circle bisects a chord, like here, OM bisects chord AB in the sense that AM equals to MB, then chord OM, then line segment OM will also be perpendicular to chord AB. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to this rule number 7. Repeat again, whenever you draw a line segment from the center of the circle that bisects the chord, then that line segment will be also perpendicular to the chord. Okay, we can implement rule number 7 in our drawing. Here we join points O and then together by a straight line. Point O is the center of the biggest circle. So from the center of the biggest circle, that is to say, from point O, we draw line segment ON that bisects chord AC. Why by ON bisects chord AC? Because AN equals to NC. And therefore chord line segment ON will be also perpendicular to AC. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 7. In conclusion, we can write down that ON is perpendicular to AC. Okay, you can write down here that ON is perpendicular to AC. But it is given us in the question that AC is also tangent to this circle point N. We define the center of this circle as Q. Then we join points Q and N together by a straight line. Point Q is the center of the circle. Point N is the point of the circle itself. Therefore, Qn is the radius of this circle is equal to B. The radius Qn is drawn to point N, that is the point of tendency of tangent AC with this circle. And whenever a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NQ. That is to say, this angle will be equal to 90 degrees and this angle equals to 90 degrees. Therefore, we can write down that QN, the radius QN is also perpendicular to AC. QN is also perpendicular to AC. And from those two equations, ON perpendicular to AC and QN also perpendicular to AC, we derive that point O lies on QN. Point O, that is the center of the biggest circle, must lie on the radius QN. Why? Because if point O doesn't lie on QN, either ON will not be perpendicular to AC or QN will not be perpendicular to AC. In order that both line segments QN and ON will be perpendicular to AC, both point O must be on the radius QN. Okay. So if point O lies on QN, it means that QON is one straight line. QON is one straight line. This line segment QON is one straight line. At this point U, this circle touches the biggest circle. That is the point of tendency between the two circles. So we draw tangent VW that is tangent to both circles at point Q. So point Q is the center of this circle, point Q is the point of the circle itself, therefore QU is the radius of this circle. The radius QU is drawn to point U, that is the point of tendency of tangent VW with this circle. And whenever radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius UQ. If VW perpendicular to UQ, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. So I can find out that QU is perpendicular to VW. Likewise, point O is the center of the biggest circle. Point U is the point of the biggest circle itself, therefore OU is the radius of the biggest circle. The radius OU is drawn to point U, that is the point of tendency of tangent VW with the biggest circle. And whenever radius that is drawn to the point of tendency, tangent VW will be perpendicular to the radius UO. If VW perpendicular to UO, it means that this angle equals to 90 degrees and this angle equals also to 90 degrees. So we found out that OU is also perpendicular to VW. OU is also perpendicular to VW. And from those two equations, QU perpendicular to VW and OU is also perpendicular to VW, we derive that OQU is one straight line. OQU, this line segment OQU is one straight line. Otherwise, if OQU is not one straight line, then either OU will not be perpendicular to VW or QU will not be perpendicular to VW. In order that both OU and QU will be perpendicular to VW, OQU must be one straight line. So again, OQU is one straight line, so we found out that OQU is one straight line. And we have only found out that QON is also one straight line. So from those two statements, we derive that NQU is one straight line, NQU is one straight line. NQU is one straight line. If NQU is one straight line, it means that NU is also one straight line. So NU is a straight line that touches the circle at point N and at point U. Therefore, NU is a chord. NU is a chord that passes for point Q. Any chord that passes for point Q is the center of the circle. So any chord that passes for the center of a circle must be the diameter of a circle. Therefore, NU that passes through the diameter of the circle, that is to say for point Q, must be the diameter of the circle. So can I know that NU is the diameter of the circle. Okay, NU is the diameter of the circle. But we also know that the diameter of any circle is twice as long as the radius. And the radius of this circle is b, so NU, that is the diameter of this circle, must be equal to 2b. NU equals to 2b. Then I presented to you rule number 9. And we implemented rule number 9 in our drawing. According to rule number 9, if two circles touch each other internally, then the straight line that connects their centers together passes through their touching point. The center of the circle is here at point, the center of the big circle is here at point O, the center of the small circle is point M. The straight line that connects their centers together is the straight line OM. And according to this rule number 9, the straight line OM must pass through point P, that is to say OMP is one straight line. Again, OMP is one straight line. So I actually can implement rule number 9 in our drawing. Why? Because in our drawing, the smallest circle and the biggest circle have an internal lines between them at this point S. That is to say, they touch each other internally at point S. And the straight line that connects the centers together is OP, because O is the center of the biggest circle and P is the center of the smallest circle. Therefore, OP is the straight line that connects their centers together, and according to rule number 9, the straight line OP must pass through point S. Or in other words, OPS is one straight line. Again, OPS is one straight line. So I can write down that here OPS is one straight line. But if OPS is one straight line, this line segment OPS is one straight line, it means that OS minus PS equals to PO. Again, OS minus PS equals to PO. Repeat again. OS minus PS equals to PO. What is the definition of OS? Point O in the center of the biggest circle. Point S is the point of the biggest circle itself, therefore OS is the radius of the biggest circle, that is equal to X, according to our definition. So I can substitute OS by X. What is the length of PS? PS is the radius of the smallest circle, that is equal to 2. So I can substitute PS OSP by 2. So in conclusion, found out that OPO equals to X minus 2. PO equals to X minus 2. This line segment PO equals to X minus 2. Okay, then we extend that the perpendicular ON by straight line until point T. ON is the perpendicular, it is absolutely a straight line. When you extended the straight line ON by straight line, the result is OT, therefore OT must be also a straight line. So if we focus on this side of the straight line OT at point N, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have with this side of 40 at point N? We have this angle that is equal to 90 degrees plus the missing angle. In total, it must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle must be equal to 90 degrees. It's given us in the question that CA is tangent to the small circle at point M. Point M is the point of tendency. We joined points P and M together by set line. Point P is the center of the small circle. Point M is the point of the small circle itself. Therefore, PM is the radius of this circle that is equal to 2. The radius PM is 1 to point M, that is the point of tendency of tangent AC. If this circle is whenever you have a radius that is 1 to the point of tendency, then tangent AC will be perpendicular to the radius MP. If AC is perpendicular to MP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. Then we do the construction, we draw perpendicular on the radius MP at point P. Again, we go perpendicular on the radius MP at point P. So this angle equals to 90 degrees according to our construction. So inside quadrangle NMPT we have 1, 2, 3 right angles. Therefore, the fourth angle must be equal to 90 degrees according to the rule that the sum of the angles in a quadrangle is equal to 360 degrees. So quadrangle PMNT is 4 right angles. Any quadrangle that has 4 right angles must be this rectangle plus a square. So we write quadrangle PMNT is a rectangle. And we know that the opposite sides of rectangle are equal to each other. That is to say PM equals to TN. PM is 2, therefore TN must be also equal to 2. Then we define the length of ON as H. And we also know that in rectangle MNPT, MN equals to PT. But MN is 7 over 2, therefore PT must be also equal to 7 over 2. So then implemented the Pythagoras theorem on the right rectangle OPT. So I copied the right angle OPT in a new page. Here, TO equals to TN plus NO, that is 2 plus H. We already found out that PO equals to X minus 2 and PT equals to 7 over 2. So this is the right triangle OPT, that is the opposite of the original drawing. Again, the hypotenuse PO is X minus 2, PT is 7 over 2, and OT equals to 2 plus H. According to the Pythagoras theorem, in the right triangle OPT, PO square equals to PT square plus OT square. Again, PO square equals to PT square plus TO square. PO is X minus 2, therefore P square is X minus 2 square. That equals to PT square. PT is 7 over 2, therefore PT square is 7 over 2 square, that is 49 over 4. Plus OT square. OT is 2 plus H, therefore OT square is 2 plus H square. Then we open the brackets on both sides of the equation and we found out that X minus 2 square equals to X square plus 4 minus 4X, that is equals to 49 over 4 plus 2 plus H square equals to 2 square, that is 4 plus H square plus 4H. Then we did a construction, actually connected points O and C together with a set line. Point O is the center of the biggest circle. Point C is the point of the biggest circle itself. Therefore, OC is the radius of the biggest circle, that is equal to X. ON equals to H and NC equals to 13 over 2. So I copied the right triangle ONC in a new page and implemented the Pythagoras theorem on the right triangle ONC. According to the Pythagoras theorem and the right triangle ONC, OC square equals to ON square plus NC square. Again, OC square equals to ON square plus NC square. OC is X, therefore OC square is X square plus it is equal to ON square. ON is H, therefore ON square is H square plus NC square. NC is 13 over 2, therefore NC square is 13 over 2 square, that is 169 over 4. So in total we found out that X square equals to H square plus 169 over 4. Therefore, you can substitute X square in this equation here by H square plus 169 over 4. We did it and we got that H square, x square is 169 over 4 plus h square, plus 4 minus 4x is equals to 49 over 4 plus 4 plus h square plus 4h. We have h square on both sides of the equation, so h square will get cancelled. We have 4 also on both sides of the equation, so 4 also will get cancelled. And we left only 469 over 4 minus 4x, that is equals to 49 over 4 plus 4h. Plus 4h. We subtracted 169, we subtracted 49 over 4 from this equation, and found out that 169 minus 49 over 4 minus 4x equals to 4h. 169 minus 49 is 120, so in total this expression equals to 120 over 4. That is equal to 4x plus 4h. Here we took 4 as a common factor from those two expressions, and we found out that 120 over 4 is 30, so 30 equals to 4. Inside the brackets we have x plus h. Then we divided the equation by 2. 30 over 2 is 15, 4 over 2 is 2. So in total, we found out that 15 equals to 2 times x plus h. 15 equals to 2 times x plus h. So what is the length of un? From knowing it is very easy to see that un equals to uo plus on. Again, un equals to uo plus on. Uo is x and on is h. So in total, un equals to x plus h. So you can write down here that un equals to x plus h from one side. From the other side, we found out previously that un is also the diameter of the circle that is equal to 2b. I show it here. un is also equals to 2b. So you can write here that un is also equals to 2b, and from those two equations un equals to x plus h and un equals to 2b, we will derive that x plus h equals to 2b. But we already found out that x plus h, it is also equals to 15 over 2, so you can write here that x plus h equals to 15 over 2. And from this equation, 15 over 2 equals to x plus h equals to 2b, we will derive that 15 over 2 equals to 2b. 15 over 2 equals to 2b, we divided this equation by 2, and finally found out that b equals to 15 over 2 is 15 over 4. So b, the radius of this circle b equals to 15 over 4 units. And we have already found out that a, the radius of the small circle, equals to 2. So the ratio b over a equals to b, that is 15 over 4, over a, that is 2. So b over a equals to 15 over 4 over 2. 15 over 4 over 2 is 15 over 8. So I found out that b over a equals to either 15 over 8, or in terms of numbers, it is equals to 1.875. Yeah, b over a equals to either 15 over 8, or it is equals to 1.875 without units. Okay, thank you very much.